So things don't get more complicated at all. They actually get simpler, I think, today, and you'll be really excited for today because today we get to start using the logic, not just reading about it. So these are the two colors we're using today. I'm going to start by highlighting the one definition, which is a proof. It's considered to be a logical sequence of statements and supporting reasons. It can be in any form. It could be a paragraph proof. It could be a double-sided proof. It could be a one-sided proof. And you will do some of those in trigonometry. But for right now, we stick to double-sided proofs for geometry. They're I'm pretty strict about you being able to do double-sided proofs. A lot of geometry teachers have gotten away from proofs because they seem like they're hard to teach, but they're hard to teach because people haven't had the logic background that you have. So you'll absolutely love it. So let's start with some facts. You know, we've been building some facts for months now. Okay, it's not really been months. It's only been a couple of weeks, but we've been building up a whole list of facts. But let's go back to some of the old ones, the ones that we know way back in algebra, because they still count. There's the addition property of equality, and these are all properties of equality. And the addition property covers the subtraction property because it's just a negative number. The multiplication property covers the division property because it is just a fraction that you're multiplying. The distributive property, ta-da! Substitution, we do that a lot. Reflexive property, symmetric property, transitive property. That's just for algebraic stuff. So, in addition to that, in this one, they're going to introduce a couple of theorems. There's the congruent statements of segments, happen to be reflexive, symmetric, and transitive. And congruent statements of these happen to be reflexive, symmetric, and transitive. And they actually let you prove them if you want. I think it's kind of, when you're asked to do a proof of something, they should not ask a student to do a proof of something that they're telling them is a fact. So for this one, I can't use that reason for why it's true. I have to build it off of other things. But you can see some examples of what proofs look like in here and how they do them. And we're going to do some proofs. We're going to do some algebraic proofs in class, but we're also going to do some geometric proofs in class so you can kind of get the idea of what it goes like. One of the things you need to understand about proofs is that just because you do it a way that's different from my way does not mean that your way is not correct. There are many different ways you can prove stuff. It doesn't have to look the exact same way to be correct. As long as all of your statements and reasons are correct, it would be okay. So don't think that it has to look just like mine or you have to say it just like mine. You have to say things that are correct. You have to say things that are accurate and things that are geometrically relevant to the problem. And if you can work your way around to it, then it's probably going to be okay. So don't think it's got to look just like mine. I think that's all for today for the highlighting, and then we'll have the class in just a minute. Okay.